Right, good evening, everyone. Good evening, boys and girls. Right, today I want to continue with the topic on interpenetration and development. I explained a lot of terminologies yesterday. Right, so today I'm going to go straight into the question, and we are still looking at offset combination. Right, remember we have got offset, we have got inline combination. But I'm going to show you what we are going to look at today with regards to this task. Right, like I said, it's still interpenetration and development. We are going to copy the given top view. We are going to complete the front view, right, which means we are going to define the line of intersection. We are also going to draw the left view, right, as well as developing, coming up with the surface development of the branch pipe. We also going to look at the labels, define all details that are required, and showing all necessary constructions as per instructions. So I want you to follow this and understand so that we consolidate what we started yesterday, right, in our preparations for the trial exams as well as the final examinations. Thank you. Please don't forget this statement. It's very important, right? For technical subjects, practical subjects, you need to be practical in order to understand what you are doing. So you have to do it in order to understand it. As much as you could spend time listening to or watching this video and so forth, but as long as you are not going to sit down and do it yourself, this will not bring results to you. So I urge you, everyone, to make sure that you take your drawing board and sit down and draw. Enjoy drawing, okay? Boys and girls, I want you to enjoy this lesson and all the best. Right, okay. Okay. Just move this case away. Right, okay. The given figure shows the incomplete front view and top view of a right regular square prism that has been shaped to fit around a right regular hexagonal prism. Right, so the views are here, right? Maybe you would want to see them before we start. There you go. Right, so we have got this, right, is what we are supposed to draw today, right? The combination between a square prism and a hexagonal prism, okay? Right, again, they are meeting today, they are meeting at right angles, right? But still, it's offset combination. They are not in line in terms of the center lines, okay? Or the axis lines. Right, we are also given point A, right, which is a point of reference in terms of our starting position. Draw to scale 1:1 and in first angle orthographic projection the following views of the two prisms, right? The top view using point A as a reference point. So if we are looking at the top view, remember it's first angle orthographic projection, we are simply going to copy this one as it is, right? And the complete front view, when they are talking about the complete front view, like I explained, right, you are supposed to define the line of intersection, okay? Right, then the left view, when you are looking from the left like this, right, what shape are you going to see? Obviously, you are going to see this square, right, in position, right, okay? Right, then from there, you are also going to look at the construction of the surface development of the branch pipe. Remember, the vertical one is the main pipe. This one would be the branch pipe, which is also seen at the top. Label the surface development. We are going to do that, and we are also going to show you all the necessary constructions that are required for you to come up with the answer for a task like this. Show all hidden details, okay? Like I said, if it is an offset position, you definitely will be able to see hidden details, okay? Inline, which means the details that are in front are basically also in front of the details which are at the back. But the moment you are able to see hidden details, what it means basically is that there is information at the back, okay, which is not in line with information in front. So without wasting time, let's look at this. Right, I want you to see the view. I want you also to see what we are doing here. Right, if you check closely, right, let me just bring this one. Right, this side of the hexagon, right, is drawn at 15 degrees. Right, so the first thing that you may want to do, right, you may want to draw a line via point A, via this point at 15 degrees, right? Then a line which is at 75 degrees. That is possible if you are using an adjustable set square. It will be fast and easy, okay? Right, let's see if I can do that. But if you are not having an adjustable set square, you can make use of a protractor measure, right? Draw a horizontal line and measure 15 degrees relative to this. Right, so let's see. 15 degrees, right? Okay, there is my 15 degrees. Right, so let's see if I will be able to draw a line via point A. Right, if I do this, take that. There you go. Right, as much as I can draw like this, supported here, I can also turn it around and draw at 15 degrees. Right, this is the line at 15 degrees like that, okay? Right, if this is 15 degrees, what it means basically is that I can also come here and draw another line. Now this would be at 75 degrees, just to make sure. Right, so I can come here, draw a line via the center as well. Right, so this one, right, is at 15 degrees. If you draw a line here, just a faint line, just to define what I'm talking about, right, the angle that is created here is 15 degrees. Now, then you check the size of the hexagon, right? It says 32 millimeters. So you would measure either here or there, right? 32 as your radius. I'm going to measure this. Like that. Right. Then from there, you take your canvas. So that it's all clear from whatever angle. Right, this. Right, take your compass, radius 32. Then describe a circle. Describe a faint circle. Right, what it means, basically you would find that there is a point there, right? If you check, right, you have got this one, which is this point, right? And this point and the other point there. So I can stand here, right, with same radius like this and same radius and mark this side, right, like that. and mark that side, okay? Right, I connect this point to there, this one to there, and this one to there, this one to there. I come up with my perfect hexagon, right, faintly at first. Right, you connect to this one. Like that. Right, okay. Right, if you are satisfied that you have done the right thing, you can outline. So we have got the hexagon. I can outline this hexagon as it is given. Right, from here to there, it's an outline. There you go. There you go. Right, so now the hexagon is in position. The next thing that you want to do, right, you project these lines going up because you shall need a height of 75. I can project, but let's start with the highest point, project it like that. Then from there, define the ground line, right, from here, like this. Right. I can label this one point X and this one point Y like that. Right, it's about 15 or so millimeters above the front view, the top view in terms of the highest point. Right. Then from there you measure from here to there, which is 70. 70 millimeters. Right, you mark a point. Then you draw a faint line like that. Okay. Right, via the actual 70 millimeter point, like that, okay? So just take this one. There you go, okay? Right, so from this point to that point, that's 70. Right, then the next thing that you want, right, is this part, okay? Right, if you are looking at this one from here to the center line, okay, or to the axis line, I need 35 millimeters. Right, I'm going to measure 35, like that. Then project faintly, like this. Right. Take these lines up. Right. All the lines, I'm taking them up, like that. Like that. There you go. I can label this point A, this one B, this one C, this one D, this one E, this one F, like that, okay? Right, as you can see, when we are looking at the actual view, right, this side and that side, in terms of what you are able to see from this end, right, from the bottom part, you are not going to have any disturbances with regards to this line. So I'm going to outline this up to there. Right, this one also, right, is very far away from the point of intersection. So I'm also going to outline this one also all the way like that. Right, but I'm going to tamper with this one, even though on the drawing it's given, okay? Right, I'm not going to tamper with this point here, okay? Right, this point, because it might interfere with the line of connection. So I'll leave that one for now, but I'm going to define this one as a hidden detail, right? Because it's on the other side, like that. Right. Maybe let me outline the top part, like this, and also outline the bottom part, like that. Okay, right. We have got a square, right, which forms the basis of the square prism, which is side 38, okay, right? We need that, and we also have got a distance of 20 millimeters from here, right, from here to there, which is our 20. Right, okay. Optimum. Right, okay. I think it's much clearer now. Right, okay. So if we are looking at this, we have got a side which is getting into the hexagonal prism, right, through that line of axis. The side is 38, okay? Right, but before we do that, we need to measure 20 millimeters, right, 20 from here. And bring this one down, like that. Then once we have done that, the next thing that we want to do, right? Let me get to this point. Just draw a faint line like this. Right? This one is in line with that, okay? Right, I'm going to define the square like that. Right, the side is 38. So I'm going to measure half of 38, which is 19 like this. Right, you need to be very accurate. Right. Then project like that. Then I can project this other side like this. Right, I do the same here. Right. Then measure 19. Like that. Let me just verify. Right, then I do this. Like that, okay. I do have auxiliary views in position. Right, I can label this point 1, this point 2. Right, if I had space, I would there point number 3, so I would put 3 here, and there point number 4. Right, then if I turn this thing, right, you would find that this point would no longer be point number 1, but now it will be point number 4, right? From 4, where did I go? That's 1, then 2, and 3, okay? Right, what you need to just know, if these ones were on the outside, they are now in the what? In the inside, okay? If they were on the outside like this, they are now inside like that, okay? Right, but that can be easily be achieved when you make use of the meter line. Then from there, you project like that. You project like that. You also project like this, all the way like that. Right, I'm going to create a line so that we are able also to project a left view. Okay, somewhere here, create a ground line all the way, right? And I'm going to define this ground line as x1, y1, like that. Where the two ground lines meet, I'm going to create a meta line like this, okay? All right. Now, if you check with regards to the views that we have here, right, we can easily take these lines from here, right, all the way. But remember, we do have our 20 millimeters from here, so I can just project this one to there, then stop for now, project this one to there, and stop there, and project this one to there, right, and stop there as well, right? Then do the same when you are looking at the top view, right? This one would go all the way to meet the surface of the hexagon, and this one like that, this one like that as well, okay? Right? From there, you can outline. There you go. Right. I can also finish the outline here, like that. Right, as you can see with point B, it's on the other side, it's not interfering with, so I can show this one by way of hidden details, like that. But what I cannot do for now is to outline this one because it has a specific point of intersection with the prism, okay, which is the square prism. Right, so let's focus on this. Now everything is in position. We have got our top view, we have got our front view, right, we have got the auxiliary view, right, but as much as we do have that, we can also come up with a framework in terms of what you will be able to see when you are looking from the left-hand side. So I can start with this, which is the square prism. Take this one up, all right, and project with regards to the square prism. Remember, this is point number 3, this is also point number 3, right? This is point 2, and this is point 2, which is also point 4, okay? Right, this is point 1, this is point 1, like that, right? So I can project that like this, like that. Now, there's something that you will be able to see, right? If we were to draw a line from here, right, from this point to there, and from here to there, and from here to there, you are going to produce the same geometric shape like what you have in terms of the auxiliary view, okay? Right, so I'm going to connect this like that. There you go, okay? Now, that's our left view, right? By projection, we project it like that. This is point 1, this is point 1, so we are also going to have point 1. This is point 3, this is point 3 as well, right? Then we have got 2, right? And you look for 2 there, and you have got point 4 there, okay? Right, this is the square prism, right? As seen from the left-hand side, right? Then from there now, as you can see, right, if we are projecting, this is our point 1. When we are looking from the bottom here, right, there's nothing that would stop us from looking or being able to see line 1, 1, okay? So I'm going to look for line 1, 1 by projecting from this point. Right, by projecting from this point, looks like slightly overlapping this one, right? Then 1 and 1, so that is the point. So there is my point 1, okay? right? And I'm going to extend this because there's nothing that would stop me from being able to see that, right? So if there's one, right, there's also one, okay, right? Then in line with one, there is also point number 3. But if you check, point number 3 is on the other side of the slope. But for now, let's just label it. That's point number 3, right? Then from there, I've got point 2, right, which is on my side here. So I'm going to project point 2 is in line with point number 4, right? So I'm going to do this where you'd find that point 2, if this is point 2, this is also point number 2, like that. If this is point number 4, this is also point number 4, like that. Right, so I'm going to extend this there and extend this one to this point. Right, it's visible because it's on this other side where I am able to see. Okay, one is at the top, the other one is at the bottom. Right, then once you have done that, you have got if you are moving from point 1 to point number 2, right, you are going to pass through this point. Okay, right, this point we can call it point M and N. Okay, right, so I'm going to extend this one and label it X and Y, right, and also label this one M and N, like that, right, just for information's sake, right. And I'll show you again, when you project these lines, you project it to the mitre line, you should be able to establish these points as well, right. So if I take back this point like this, okay, right, the first one, right, I would call it X, right, but remember there is also from 1 to 2. 2 is on the other side here. So between 1 and 4, there is X. Between 1 and 2, there is Y. So in line with this one, I've got 1, right? Between 1 and 2, and between 1 and what? And 4, right? And I also project from here, right? I've got this one, M and N. It's between 2 and 3, and between 4 and 3, okay? Right, if we have got this point number 2, you would find that it will be this side. Then you have got 3, then you have got 3 to 4, okay? Right, these same points, you can transfer them to the top view, okay? Right, so you can take the distance between 4 and 1, which is X, okay? Right, you can take them like this, right? That is my point 4 towards point 1, right? I can come here and establish, right? So that would be my X, okay? Right, so whenever I have got F, I've got X and Y. Wherever I have got A, I've got M and N, okay? Right, I can also take the distance between 3 and 2, right? Starting from point number 3, and you mark there. You have got M and N, okay? All right. Now, let me show you something, right? If you project this one to establish the framework of the hexagonal prism, right? Let's project point B like that. Then you take it up like that. Then you project point C. You take it up like that. Then you project point A. You take it up like that. Then you project point F to the mitre line. You take it like that, okay? Last but not least, it's point D, not last. You take it up like that. Then it's also point E, which is on the outside, not interfering with the square prism like that. So there are certain lines. So I'm going to say this is point E, right? This one is point B, right? Then you have got point C, which is on the other side. Basically, that will be hidden, right? Then you have got point D, right? You have got point A, which is here. Remember, we said point A is represented by M and N, okay? Right? Then you have got point F, right? Let's see, point F, right? Which is here, right? Okay. Right, then we have got point D, right? Remember, this is B and D, so we can also outline this, right, at the top, like that, and also outline this at the bottom. Outline this is not interfering with the square prism, and this one too, not interfering with the square prism, okay? Right, this shape can also be outlined. Like that. There you go. Like that, okay? Right, so we have got point A, right? And we also have got point F, right? Point F is representing X and Y, and we've got point A representing M and N, okay? Right, M at the top and N at the bottom. Right, remember, if we projected this is our point A, right, which is here, right? We take this one up all the way, right? It should meet with line, right? If I project like that, right, you would find that this point M, which is the same as this one, they are going to meet here, okay? Right? Then you have got point M, which is at the top, between 4 and 3, right? This is my 4 and 3, which is on the other side there, right? If I project from here, like that, you would find that it is basically the same point as well, okay? Right, M, right? I'll start M, it's between 3 and 4, okay? Right, where is my 3 and 4? Right, which means it's at the top there, right? Which is this one. The distance from here to there for 3 and M, right? 3 and M, okay? So you take this one like that, okay? Right, starting from point 3, right? But point 4, you have got your M, okay? Right, which should be one and the same point like that, like this. That's M. Then the other one here, it's N, okay? Right, so I've got my point M, right? What it means basically is that I'm going to extend this one to this point and extend this one to that point, okay? Right, which is the same as this one, that's your M, this one, that's your N. If by projection you take that, N at the bottom and M at the top, right? Right, if you take this one, you'd find that you have got point F, right? What it means is that X at the top and Y at the bottom, right? If you project this one, you find that will be the point. Then the other point is on this other line between, this is 0.4, this is 0.1, this is 0.2, and the other one will be next to point number 3, between 3 and 2, okay? Right, you'd find that it would give you that point as well, right? So if you project backwards, right, like that, so the A is this point and that point, so I'm going to extend this line like this, and extend that line like that. Right. Let us start. Right. From point number 1, I go to point X. Okay. Right. I go to point X. Right. Where is my point X? I project from here. Right. There is my point 1. Right. I should go to point X, then to point number 2. Right. Okay. In fact, if we are coming from here, you go to point Y, okay, which is this point. Then from point Y, you go to number 2. From point number 2, you go to N, right, which is this one, because we are starting from the bottom. But if we were starting from the top, you were starting with X and Y, right? So it's 1 to Y, Y to 2, 2 to N. From N, you go to number 3. From 3, you go to M. From M, you go to 4. Then from 4, you come back to X. Then X would take you to point what? 1, which is, there is no direct link from here to number 2. You need to pass through this point, okay? Right. So if you have got an auxiliary view like this, which is our left view, what it means basically is that if you have got point number 2, from point 2, you go to N, okay? Right. From N, you go to 3. From 3, you go to M. From M, you go to 4, okay? Right. 4, you go to X, you go to Y. 1, Y to 2, like that. So let's join this point from here to there and from here to there. So the first point that we want to connect, right, in line with this would be from here to there. Right. Then from Y, we go to point number 2, which is this one. Right. Then from 2, right, 2, we go to M, which is our N, like this. Right. From N, we now travel to point number 3. Like that. Then from 3 to M. Right. You connect this one. Then you come back. Now, this is our point X. From 4, you come here like this. Then you go back to the starting point, which is your point number 1. Right, remember what I said from the onset, there was an outline which was here, right? But this outline, as you can see, is now interfering with the line of intersection, okay? So we here to this point, that is the connection between the hexagonal prism as well as the square prism, okay? But before we do that, let's define the curve of intersection, which is this. There you go. Then you take this one down. Right. This is what you'll be able to see from the outside, okay? Right. These are the details that you'll be able to see that are clear, that are visible, but there's also other connection points which are at the back. Right. Remember, the moment you reach this line, the points of connection now are on this slope, okay? And you won't be able to see those details. So there we represent those details by way of hidden detail lines. So I'm going to show here, that's the hidden detail line. And back to point number 1. Number 4, sorry. Like that, okay? Right, that would define our line of intersection. That would define our line of intersection with regards to the front view. Right, from 1 to 1, right, from this point number 1 to point Y, from Y to point number 2, from 2 to point N, I'm dealing with the ones at the bottom, right, from N to point number 3, from 3 to M, from M to point number 4, from 4 to X, from X to point 1, you are. Now, what it would leave us would be able just to define and outline the details that you'll be able to see here. Right, so if we are to projected this one, because we have got this part, we would extend this one before we come to the conclusion, but you also need now to connect this one to the Y point, okay? Right. You skip the line of intersection, you do the same, you connect there, okay? Right, so now this is now factored in. It's now in position, right? The next thing that you would want to do now is to define the end view as a complete entity, okay? Right. I've got all the details. A, it's represented here, so I can even say A, this is point A, this is A, right? The hidden detail is B, which is B, right? This is E and E. Remember, there are no specific marks for labeling like I'm doing right now, but as you have realized with the lessons that we have been doing, labeling would enable you to coordinate points and be able to explain something to someone, okay? Right, if I was just doing an examination on my own, perhaps I may not be able, not want to label anything, but because I want to show you how this is established, labeling is very critical, okay? Right, then F, which is this point F and point F like that. Right, okay. So we have copied the given view, which was the top view, right? And we also completed the front view, right? The front view by defining the line of intersection, okay? Right, then we now want to draw a left view. Remember what I said from the onset, you tick, right? I've done that. That is the top view, right? I completed the front view. I now on the left view, right? So let's see if we are going to complete that. I've got everything in place in terms of the framework, right? So if I'm to project this, this is A, okay? But project this to the mitre line, what it means is that A would be stopped here and then goes all the way at the top as well. So I'm going to draw this like that. Okay, when you are looking from the left-hand side, you do the same for F, right, which is here, then you take it up, then it is going to be stopped by the prism there and there, okay? Right, so as an advice, the moment you have got a side view, it could be a left view or a right view, draw that and directly project from the left view or from the right view to the front view. You'll find that the coordination between the top view and this would give you these points, okay? Even without labeling anything, you should be able to get these points by simply projecting like that, coordinating, projecting like that, coordinating, because this would show you the actual positioning. Then if you project like that, it would automatically give you this and also give you that. Right, okay. Then we have got point C, right? We did not disturb anything with regards to point C. So I'm going to show hidden details if I'm looking from the left-hand side all the way. Like that. That is the issue of visibility if you are looking from a specific direction. Right, the same applies with point D, right? There's nothing There's an edge in front, even if you are going to pass through an opening, but there's an edge behind. So that edge has to be defined by a hidden detail. That's right, okay. Then from there, you have got point E. We have already defined point E. We have already defined F, right? Which we say if it is a prism, it is FFEE, right? And this one is DD, and that's AA, BB, and CC, like that, okay? Right, then we have got this one is already there, then point B is already there. Right, so that is typically our left view, okay? Right, so I'm going to label this one just to make sure that it's clear. Right, this we created, we did not copy, so we label left what? Left view. Like that. That's our left view. Right. So once you have done this, okay, right, is there any particular detail that we've missed? No. Right, okay, so you are going to tick on the task box, right, that I did the left view. Right, the next thing that you would want to do, right, is the surface development of the branch pipe. This is our branch pipe, which is here, okay? Right, so we want to open it out such a way that we are able to create a template, a pattern, okay? That pattern, if it is material, would cut that according to the size which is required. So let's see how we are going to do that. But remember, if I had space here, it was not going to be an issue. It's just a matter of drawing a line along the baseline, then projecting. But we don't have space there. So what I'm going to do, I'm going to draw that development here, right, going up. Let's hope it's going to fit. I'm going to do this, just a faint line like that. But find the starting position. Right. Find a starting position and mark, okay? Right, I'm going to open through point 4, right, such that I've got 4, 1, 2, 3, which is on this other side, which is here, as you can see. Right, so I'm going to have point 4, 1, 2, 3, 4, okay? Right, how do I do that? You take the measurement, the actual measurement between 4 and 1, right, which is the same as this, because this is 38, and step 4 times. This is 1, that's 2, I should come back to point number 4, that's 3, then 4. Right, you can also verify to check if you have got 4 sides. So if you have got point 1, point 2, point 3, back to point what? To point 4, okay? So it's 1, 2, 3, and 4, right? The next thing that you want to do, right, is to take the highest measurement, which is 1, 1, from here to there, okay? Right, you can take from here to there, you can take from here to there, it's one and the same thing. Take this measurement like that, right? Go to point 1, but before you do that, maybe you just need to draw some horizontal lines like that, faint horizontal lines like that, okay? Then mark, this is point number 1, okay? Right, I'm done with point 1 here, right? Then I can also take the same thing, point number 2, which is point number 4 as well. You take this measurement, right? You take from the base to the point of cutting or the point of intersection, okay? Right, which is the same also for 2. But you can either take here, it's one and the same thing, right? So I go here, right, and mark, okay? This is for 2 and 4. So I'm going to just draw a faint line like that, okay? Right, so the other 4 is here, the other 4 is there, there is my point 2. Right. Next, the other one which I want is number 3, right? I take number 3, right, from the base to the point of intersection, go to point number 3. Okay, right, I mark that, right? So this is my point 3 as well, right? Now, once you have done that, you still need to consider this. You have got 1, 2, to y, then to 2, okay? So between 1 and 2, there's point what? Y, right? Between 1 and 2, there's point y, which is the same distance from here to there, or you can take it from here to there as well, okay? Right, so you can do this, right? I think what is easier is to take the distance from 2, right, like that, to x, right? So between 2, right, between 2 and 1 and 2, there's point y, okay? Right, so I come here, standing at position number 2, right, like this, right? I mark, standing at point number 2, I mark. This is the line in line with point number what? Number y, okay? So there is a y there, right? Between 1 and 4, okay? Right, between 1 and 4, there's x, right? Where is my 1 and 4? Right, which is here, right? Which is the same thing. You take the distance between here and there, right? You bring it here and mark like that. There you have got your x, okay? Between 1 and 4, there's x. Between 1 and 2, there's y. Between 1 and 2, there's y. Between 4 and 1, there's x. Then you project like that. Right. The next one that we require is m and n, okay? Right, which would give us this distance from here to there, right? Which is the same as from here to there, right? If this is point number 4, 1, 2, 3, okay? So between 3 and 4, right? There is point 3 and 4. There is point M, then between 3 from here to there and the distance from here to there, it's basically the same. Right, okay? So I'm going to M, right? So you can take the distance from here to there, right? Like this. Go look for point 3 towards point 4. Point 3 towards M, you mark, okay? Right, that's your point M, right? Then between and 2, right? Standing at point 3, right? On the other side, you have got your N, right? Standing at point 3 towards point 2, your N, okay? But you mark also like this. Right. Now you have got point N. Project these ones up like that. You project this